What's up, guys? So I had my son go and do these trials for me and then create a dot plot. I had to go back through it because he missed one of the 4s, but it's all good. I got it to make sure that these added up to 50, of course. And why would I make you do a dot plot? Well, as you're entering this data into a calculator, it's 6, then 2, then 4, then enter, then 6, then enter, then 4. And you have to keep looking for all these digits. If you do it like this, well, I used the calculator app that we were looking at here, and I just started with 2222 because I knew I needed 4 of them, okay? And then, of course, I would get something right now, wouldn't I? I would get 3 3s, and then 15 4s, and then 11 5s, and 6 11s, and so on. Or, excuse me, 11 6s. And I put all of that in, and basically I added up as I went so I could see which term I was going to be on. Like when I was done with 4s, well, I should have went through term 22. And I can kind of double check myself. Sure enough, 23rd term is 5. I should have went through, of course, 33, and so on. And you can see I just put all of those values up in there, okay? All the way down to, of course, where there are 50 items. And the 51 kind of tells me, okay, good, I have 50 items. If you remember next, we would go to, you have to get out of here. So second mode is second quit, okay? Then you go to stats. Then you go to calculate. And you go 1 var stats. And of course we go second 1 for second 1 for L1. Okay, I press enter. And it gives me the numbers that I want. Okay, it gives me that the mean is 4.88. Okay, so I'm going to write that down. 4.88. And it gives me a standard deviation of 1.54. For the sake of what I'm trying to do here, 1.54. I'm going to kind of make this easy and call this about 4.9, and I'm going to call this about 1.5, and that's going to just in terms of what I'm trying to do here, okay? So let's think about where the standard deviation and the mean are, or where the mean is, excuse me, on this graph, which is about 4.88, 4.9 or so, somewhere right around there, you would say, okay? And then if I go up by 1.5, well, that would give me 1.5. That would put me about 6.4 right there. Right? If I go 1.5 the other way, well, minus that would give me 3.4, so that's right about here. So this is within 1 standard deviation. Now, if you remember that there was a rule, 68, 95, and 99.7, we're going to do that again today. That's called the empirical rule. It says, well, 68% of your data falls within here. So if I add this up, 15, 26, 37, out of 50 is 74%. So that's a little bit higher than what you would normally expect here, right? All right, so let's go another 1.5. So 6.4 to 7.9, which is right here. I would go from what did I have? 3.4 down to down to 1.9. Right? Am I doing that right? Yep, exactly. Okay. So that includes obviously all the 2s. Okay, I'm obviously doing this on the fly here, but that is within 2 standard deviations of the mean. And what you'll see here is all of them except for these 3 here, because 7.9 was kind of my marker, so I don't include those 8s. Well, 47 out of 50 is 94%. That's pretty dang close, right? And then one more standard deviation, right? So add another 1.5 and 9.4. Well, we're over here, but it doesn't matter. And then I get everything in, which 99.7, that's pretty close to that, right? So let's talk about a couple of vocabulary terms. What we're trying to do here, first of all, is have you see that this is a normalized curve. We're going to talk about that as we go forward, where you can find, again, about 68% of the data within 1 standard deviation of the mean. You can find about 95% within 2 standard deviations of the mean. And within 3 standard deviations, again, it's 99.7. We're going to revisit that in a little bit. Let's talk about percentile. Percentile is the number of data values at or below, we have seen this before, a value. Okay? And big thing, at or below. Okay? At or below. Z-score, well, we've done this before, if you remember, is the number of standard deviations, sorry, that came out funny, from the mean, which of course is the average, right? And if you remember, we had these funky symbols. This was like x1 minus mu over standard deviation. Maybe we rewrite this as x minus x hat over standard deviation, right, where this was the value minus the mean or the standard deviation. Okay. We're going to kind of go at a couple of pages here, and really it's more about you seeing what I'm doing here and understanding it. So I'm going to flip the page here. I will post all these notes as well, okay, so you can see them while you're maybe listening to this. So we want to find the percentile of 71 inches in this picture. So again, it is, what we're going to do here is we're going to find, well, where is 71 inches? 71 inches right here, right? That's 71 inches right there, okay? And so for percentile, remember, it's at or below. So how many numbers are from here down below? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There are 20 dots below that. Now, knowing that this is 25, I probably could have just taken those 5 away and I would have got 20 as well. Okay? So to find the percentile, you take the number of terms at or below and divide it by the total terms. So in this case, I would literally just go 20 out of 25. And what I get, of course, is 0.80, which means I am in the 80th percentile. And that's actually, you don't write 80%, right? We write 80th percentile. Okay? So I'm going to come down here. I'm going to have you guys find this one in just a minute. On 3, it says find the z-score for 68 inches. Well, of course, remember it's the value minus the mean, which in this case is telling us the mean. We didn't have to go find this. It's 67. Divided by the standard deviation, which again is telling me is 4.29. And when you divide that in your calculator, you get, well, 0.23. Now remember, percentiles are percents and so on. Z-scores are almost always between -3 and 3, if you remember that. Okay? Maybe pause it a minute. Maybe see if you can find the answers for 64 inches, number 2 here, and see if you can find the answers for 74 inches here in terms of the z-score and the percentile. Use what I showed you here. Just try it out yourself. Press pause, come back, see the answer. All right, so for 64 inches, again, that's here. And we need at or below. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 of these at 64 or below. So I don't just count the first one I see. I have to count all of them I see at 64 or below. So again, that is 9 out of 25, which is 0.36. So of course we get the 36th percentile. Hopefully percentile now makes a lot more sense. Okay. For z-score, again, 74 minus 67 over 4.29, I get 1.63, and that's that. Okay. There's one more problem that I want to just talk about that you're going to see. I'll call it problem 2.5 because it kind of fits in between here. Okay. What height, you're going to see this, is at 60th percentile? Okay, so what height is at the 60th percentile? So again, if I know that percentile, well, let's kind of take a look to find my decimal here, right? I took the number of terms at or below and divided it by the total number of terms. Okay, so if I want the term number, if I wanted to get rid of this, I would kind of times total terms to both sides. So really, I can do percentile times the number of terms, and that's equal to the term number. So what height, right? So I've got the 60th percentile, which is 0.60, okay, times 25 total terms equals, well, the 15th term, right? This times this is 15, trust me. And the 15th term, well, that's where I go start looking at this, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The 15th term, no matter if you start from the top or the bottom, is going to be 68. And again, what is it asking? What height? So 68 inches. That would be my answer to that. On your homework, you're going to see this for sure. Okay? All right. So ordinarily, I would have you go through and just try these. So if you'd like to maybe just try a few more and see what it's asking here, press pause a second, try these here, come back, check the answer. Okay, so again, it says percentile rank. So percentile rank is going to be, well, 28 because $10 million here, if, again, knowing this is 29, that's the 29th term, that's the 28th term. Out of 29 total terms, gives me 0.97. Well, it's actually 0.9655. Maybe I should write that. And that is in the 97th percentile, because you would round it. Similarly, on the next one, for $6 million, well, maybe you have to count from here. I will just tell you, because I've done this to save time, that it is the 22nd out of 29.7586, gives me the 76th percentile. The z-score for 8 million, hopefully you can do this now, would be 8 million minus, well, the mean, which is 3388617, divided by 3767484, because that's what it tells me is my standard deviation, and I would get 1.22, because we always round these to 2 decimal places. Okay. All right, let's keep going here. So we've got this normal distribution curve. These notes are going to go a little bit fast, at least on this page here. Okay, where it's talking about symmetric bell curved area under the curve. This is, of course, x hat and the standard deviation, just to remember that. Real life data is approximately normal. We've talked about this briefly before you left. Different examples is SAT scores, height, animal measurements like length of tails and stuff like that, animals, and IQ scores. There's other examples. You'll see them as we go here. But then again, we go back to this picture, right? Within 1 standard deviation of the mean, 68%. Within 2 standard deviations of 95, within 3, 99.7. So the middle, 68% of the data are within 1 standard deviation of the mean, right? The middle 95% are within 2 standard deviations of the mean, and the middle 99.7% are within 3 standard deviations of the mean, okay? Don't worry about the letters. You know that that means standard deviation. Just think of that, right? So we know that if this is within 68%, a couple of things to foreshadow here, that this can be split up into 34 and 34, right? We know that if this is 95, that that's 47.5 here and 47.5 here, and we can do some things around that. And that's really what the next couple of pages are about, okay? So when we look at this, sorry. Well, this is going to be a long video. I guess you'll have to pause it in chunks, I guess. The amount of average snowfall for Holland, Michigan is 75 inches with standard deviation of 8 inches. Probably pretty typical. We had a little less than that this year, I believe, if I remember correctly. So what percentage of snowfalls are between 67 and 83 inches? And then it starts adding these other questions in here. So what you do here to do these problems, and this is something you're going to want to do, is you set up the 3 standard deviations tables here, right? We're going to put the mean in the middle, which of course is 75. I'm going to do that in all of these. And I'm going to draw my normal curves. Don't judge me. Alright, so we've got within 1 standard deviation, again it's telling me standard deviation is 8 inches, so that's to 83 and to 67 within 1 standard deviation of the mean, and that is 68%. So again, kind of going back to what I was saying before, if 68% are within the middle and 100% makes up the total, we can go 100 minus 68 to figure out that these parts right here would make up 32% of the rest of the graph. So that means we can split this into 16 and 16 because it is symmetric, right? So similarly here, we go 2 standard deviations out, and I've got 91 and 59 within 2 standard deviations. So again, that's 95, right? So I know that the rest is 5%, so this is 2.5% out here and 2.5% out here. Again, all of it is 100. 3 standard deviations is 51 to 99. And of course that is, right here, 99.7%. So what's left from that is 0.3%, which is 0.15 here and 0.15 here, right? 30 divided by 2 is 15. Now all this stuff is really easy. We can just look at this. What percent are between 67 and 83? Sweet. Between 67 and 83 is 68%, or 68%. Okay. 95% are between, well, 59 and 91. Right. 99.7 between, well, 51 and 99. We have that from, again, our picture down here because we split them up. I did this really fast, by the way. You probably won't do it that fast, but it's the same format. I'm going to show you another one in a second. Percentage of snowfalls less than 59 inches. So here's 59, right? And the ones that are less than that would be here, and lower, so that's where 2.5% comes in. Okay. What percent of years have snowfalls more than 83 inches? Here's 83 right here, right? More than that would be 16%. What have snowfalls more than 75? Well, that's kind of silly because 75 is right in the middle of all of these, so that's just 50%. Okay. There's another page here, okay, where we would redraw this and go through it, but I'm actually just going to show you this one because I already have this one filled out. Okay, so first of all, I would do, and you can kind of see it, maybe if I turn it sideways here. Yeah, there we go. I drew them on the side of the paper because they were a little bit big, but between 68%, here's my mean. My standard deviation is 10.5, so I went 10.5 in either direction, got those. So again, I know that this is 16 and 16. Again, I know that this is 2.5 and 2.5. And again, I know this is 0.15 and 0.15 because I know what these numbers are. 100 minus that was 5 divided by 2. 100 minus that is 0.3 divided by 2, and so on. Okay. Now that I've drawn these pictures in, the rest of the stuff comes pretty easy, right? I can see between 68% are between, well, again, I go down to these two numbers, right? 95% was between 79 and 121. 99.7 between those two numbers, easy. 16%, okay, so less than 89.5, well, that's this one, 16%, right? Some of these are going to be a little tougher. Greater than 121, well, here's 121 here. Greater than that, 2.5. Less than 68.5, here's 68.5, right? 0.15. Between 100 and 110.5, okay, so here's 110.5, here's 100. Between those, if you think about this is all 68, and this splits it in half, then this would be 34 and 34, right? And hence, 34% are between 100 and 110.5. And it gets a little crazy. Actually, this one's not so bad because it says between 79 and 100. Well, that would be half of that, and half of 95 would be, of course, 47.5. For the last one, though, between 79 and 110.5. Well, look, 110.5 is on this graph. That's not 79. 79 is over here. What we can't do is just add this half and that half. Or can we? Is it that easy? Well, between 79 and 100 is 47.5, right? Okay, so that we know. We also know between 100 and 110.5 is this distance here, 34. So yeah, it was that easy. We just added 47.5 to 34, and I get 81.5%. Okay? All right, let's check out the next page after that. Because that is your homework, ladies and gentlemen. Okay? I am posting the answers to this on Thursday, okay, as well as filling out the next homework notes, okay, the next part of this chapter. I'm going to finish this chapter over this weekend next, and then when we come back from spring break, we'll start trigonometry or sequences. I'm not quite sure where I'm going to go yet. But this page here, again, this is in the it'll be in Google Classroom. It's going to be hard to just do it from here. If you print it, it's okay, but it's a little easier to draw this picture as 3 of these, right? As 3 of these. And filling out just like I did in the notes. Again, just to get another look at it, if you do a picture like this, or if you do a picture like this, it's going to be a lot easier to fill out all of these questions that it's asking, right? Okay. So, without too much information, maybe the first two are just thinkers. Down here again, they're giving you one picture for all of it, so this would be like 180, and one standard deviation would be 205 and 155. Another standard deviation away would be 230 and 130, and then 105 and let's see, 255. And then you have to think about what's within 1, what's within 2, how much in the percent. So again, split it up into 3 graphs makes all of these questions be a lot easier. Same thing for this one. This is just a completely separate. So these problems are one set of questions. These problems are a separate set of questions. What number 10 is asking, same thing as number 3, is just to do these 3. Rather than do it on this picture, same thing here. It's got all these verbiages. Don't let that screw you up. That literally means, this just means to draw 1 standard deviation out. This just means to draw 2 standard deviations out, and the last one again just means to draw 1, 2, 3 standard deviations out. Okay, I did that a little backwards, but hopefully you understand what I'm saying. Again, I'm kind of giving you the first one already. Just split these up and put one graph with these three numbers, and then one graph with those two numbers with 180, and then the last graph with these two numbers and 180, and working from there, right in your percents. Solve the problems. This has been long enough. Sorry, 20 minutes is a long video. I'm going to try not to do them that long in the future. But this is the first one, and I got to get a feel for it too. I don't think I rushed through anything. If you have questions, shoot me an email, jsearsma@hollandpublicschools.org, jsearsma@hollandpublicschools, all one word, .org. Okay. And I will answer you most likely in a pretty expedient fashion because, you know, I don't have a whole lot going on over here either. Hopefully you don't have a whole lot going on either and you decide to do a little math. Can I hold you accountable for this? No, but I may rush through this the first couple days if we come back, or if we start doing some digital learning in the future, I might even start with this. We'll see where we're at. So please get to it. Just doing basically 1 through 17 on a different sheet of paper here. I will post this again on Google Classroom so you have a blank copy. Have a good day. Hopefully everybody's doing okay. Love you guys. Later.